again, we have 3.3a here, and it's called Understanding Equations with Two Variables. Those two variables are usually going to be x and y. So to kind of start us out here, like in a plane like this, the x variable, the x-axis, will be the horizontal axis usually, and well, like always, and the y variable will be the vertical axis. Okay, and in a table, it's always going to be like x is going to be the first column or the first row, and the y variable will be, or should be pretty much always, the second column or the second row. And a couple decently important vocabulary words for x would be like, the x is normally the input, and we would consider y the output. Or more so here, we're going to be looking at how x is like the independent variable, and y would be like the dependent variable. Even if it wasn't about x and y really, and it doesn't even have to be about like the xy plane, if you're just making a graph, right, where you label this, like we label the vertical side of your table one way and the horizontal you label with something else, the independent variable should be along the bottom, and the dependent variable should be along the side for the vertical axis. And the same goes for like a table, okay? Again, like especially if you're not thinking about just like x and y, like if it was just actual variables like someone's speed compared to with their time of their trip, whatever, just random variables, whichever one is independent should go in the first column or the first row, and the one that's more dependent should go in the second column or the second row, right? And I think that's all I want to point out there. A couple decent examples, and this is where I can get into really what dependent means. If you have two quantities of something, two variables, sometimes you can have one that like definitely depends on the other one. Okay? Like, I think maybe a good example is the number of people that you could expect to go to the beach on a given day would depend on what the temperature is. Like you could say that the temperature is independent. The temperature is on its own, it could do whatever, it's independent, and then the number of people that would go to the beach depends on that. I don't think you can take that example and turn it the other way around. I don't think you can say, well, the temperature is going to depend on how many people go to the beach today. That's not how that works. So as far as like the two variables of, you know, I'll even write it as like a number 3. number of people at the beach and the temperature. So I think in this example, clearly the dependent variable is the number of people at the beach, and the independent variable is the temperature, because one definitely depends more on the other. In number one, you're making a batch of cookies and need sugar for the recipe. Well, I mean, you could probably spin this both ways. I could see how you could do that, but for now, just for the sake of understanding what dependent and independent mean, let's say, you know, the amount of sugar that you need would depend on how many cookies you want to make. So I know you could spin it the other way, but like you could say, well, I mean, the number of cookies I can make will depend on how much sugar I have. But for right now, let's just kind of say that you want to make a certain number of cookies, and so like the number of cookies could be a little more independent, and then based on that, you know, the amount of sugar you would need depends on that. And then number two, let's say that the amount of snacks you can buy will depend on how much money you have. It makes, I don't know, it's like you could definitely spin it the other way, but if we only have $20, then I think then the amount of snacks would depend on that. I know you could easily describe a situation where like the amount of money that it will be will depend on how many snacks you buy. So I don't know. I think the best example here is number 3, and because again, it's really, those are regular words in the English language: independent, dependent. So they shouldn't be too hard to wrap your brain around. It's all about which variable will depend more on the other one. All right, this is a pair of really important vocabulary words. The domain is defined as the set of all x coordinates you have, like in a relation. And the range here, I know we already did something with range. It was a totally different situation, because here the word range is going to be the set of all the y coordinates. So again, please be aware that this is one of the only situations in math. There's a few of them, but range is one of the only words that can have a double meaning depending on the different situations. So here, range is going to be the set of all y's. Now again, it's like so easy to remember because we always say domain and range. We don't ever say it range and domain. Just like we always say it x and y. We don't say y and x. So basically, domain and range, that's how they're said together. Domain and range, x and y. Just like peanut butter and jelly. You don't say jelly and peanut butter unless you're weird. Or you say aunts and uncles. You don't say uncles and aunts. You say brothers and sisters, mom and dad, whatever, right? Domain and range, x and y. Also kind of an alphabetical order thing going on there. So it's not, but you need to learn that and remember that. Domain is the set of all x values. The range is the set of all y values. So these examples here, 1 and 2, so easy. The domain would be all the x's. -2, 3, 5, and 10. Because all of these ordered pairs go x, y, x, y, x, y, x, y. And these x values are already in order. Don't be surprised if that's the way they are shown in like a multiple choice answer or something. But the range is all the y's. And again, don't be surprised if these would be like in numerical order, because they're not right here. Number 2, same thing. You should try this on your own, probably. Pause. And the domain would be -9, -5, 3, and 12. I wonder if there's going to be any repeats. 0, 11. Nope. So I will say this. If there were any repeats, you would not have to list them twice. For any repeats, you shouldn't actually. You shouldn't list it twice or 3 times just because it was repeated. You don't need to do that, and you shouldn't do it. The range, 0, 11, -6, and 54. It's just all of the y values. And again, don't be surprised if you would have, or are supposed to put them in order, or you would see them in order numerically as multiple choice answers. Number 3. I mean, I'm gonna fast track this just for this. I mean, look at it, as easy as this was, and I call these lists. LISTS. I say this was presented to you as a list of ordered pairs. So as easy as that was to point out the x values and the y values, this is even easier. Okay? And, I mean, there's no repeats here, right? So this would be the domain, all those x values in a list. And this would be the range, all those y values in a list. And so, gosh, that's as easy as it gets when they give it to you in a table and they ask for the domain and or the range. But number 4 and number 5, different story. Different story, people. Okay, so this is given to you as a graph. Now, please don't forget that a graph is like a cluster, an infinite number. I mean, I'm not even going to go. I mean, it's all these points everywhere. And all of these points have an x value and a y value. Same with over here. I mean, there's dots everywhere. And again, I don't know if I already said this a few seconds ago. There is an infinite number of these points that make this graph. I mean, if one of these graphs or both of these graphs would have just been like separate dots, like scattered around, and there only would have been like 10 scattered dots or 8 scattered dots, that would have been a whole lot easier, or I guess simpler to wrap your brain around, because that would have been only so many points. But these two graphs are an infinite number of points. So guess what? The domain includes an infinite number of x values and an infinite number of y values. So what do? We can't list them all, but here's what we can do. We can give like an interval of them. Now, if you look at this first graph, okay, and you think about, well, what's like the furthest x coordinate to the left? Like, how far left does this graph go? What's its leftist most x value, and then what's its rightest most? Like, how far to the right does the graph go? What's its largest x value? And I hope you can see that, all these possible x coordinates would go from like -2 to +2. And so it's kind of like, and everything in between. And so let me throw something at you here. that is one way to say it. I think you should start to become, like, if nothing else, I want to plant a seed here and introduce you to this kind of notation. It's called interval notation. And what this means is that it's everything in between -2 and 2. It's an interval. And the brackets mean that we are also including the endpoints of -2 and 2 in our interval. The other way to say it, I know we haven't gotten to this kind of like inequality thing, but the other way to say the domain is -2 is less than or equal to x, which is less than or equal to 2. So you could say it either way. Okay, you could give the domain as this, or you could say it as this. This is actually called set notation, especially when you include curly braces and whatever. We can call it, like, it doesn't matter. That's one way to say what the domain is. That's another way to say what the domain is. The range, remember, the range is all of the y values. So it's like, I know there's an infinite number of them, but can we give like an interval? I mean, does this graph go down forever, or is there a lowest y value that we're going to? And does the graph go up forever, or is there a highest value for the y coordinates? And it turns out that the lowest we go here is -5 for the y coordinates. Like this dot would have the lowest y coordinate, and this dot would have the highest y coordinate. Just like this dot over here had the lowest x coordinate, and this dot over here had the highest x coordinate. So the range using this interval notation would be -5, 5, and that's an interval from -5 to 5 and everything in between. In other words, my y values, -5 is going to be less than or equal to y, which is less than or equal to 5. That means everything in between -5 and 5. Pause the video and see if you can do number 5 here, this next for the circle. Okay, so the domain is going to be equal to, it looks like, from like -5 to 1 for my domain, and everything in between. And I mean everything, like decimals and everything. And the range, how low of them, so looks like -1 to 5. Including -1 and 5, and everything in between. Alright, so that was all about domain and range. Again, it was like really easy to point out the domain and range. If what I give you is like a list or a table, it's a little trickier with graphs, but I think you'll get it. Especially, when you follow up in Algebra 1 and Algebra 2. But the next couple of vocabulary words, this is a monster. What happened to the pen? This is a monster vocabulary word. Function, oh my goodness, you don't even know. But a relation, starting with a relation, is a set of ordered pairs, which basically just means a bunch of points, x, y. Ordered pairs are of x and y, pairs of x and y to make points. And so that's it. So what I always say is, if all it takes for something is to be a relation, as if it's a bunch of ordered pairs, that means like any table, any list, any graph in the plane, any equation that involves like not just x and y, but any two variables. Anything would be, because ordered pairs don't have to be x and y. It could be m and n. It could be a and b, whatever. So that's all it takes to be a relation. But a function is a relationship, so it's a relation between x and y, or whatever, m and n, or whatever, but pretty much every time it's x and y. So it's a relationship between x and y where for every value of x, there is one value and only one value of y. Spoiler alert, this is what's true, like, it's going to end up being true almost every time, especially with like equations and just things you do outside of this lesson. You know, if you have an equation or a graph or something, it's probably going to be a function. You know, like, let me elaborate a little bit. If I say, here's an equation, so it involves x and y, so it's definitely a relation. But is this a function? Well, this definition is essentially saying, okay, and this is what a lot of people think of. It's like, if I input a number for x, if I input something, am I only going to get one answer, or could I get more than one answer? Like, if I plug in a 10 in for x, how many answers are you going to get for y? Aren't you just going to get one answer? You know, so again, like, that's what I mean, where things you work with are probably going to be functions where, like, if you input something in for x, are you only going to get one answer for y? And that's normally the case, especially outside of this section. But here's a table where this is a function and this is not a function. And what you should write down is, for a function, okay, the x values are not allowed to repeat. That's a very quick, effective test of whether something's a function or not, especially if you're given something like a table or just a list of ordered pairs. If you see any repeated x values, it's not a function. Like here, the 1's repeated and the 2's repeated for the x's. And so those were not functions. And then here's an example of a graph that is a function. Here's an example of a graph that is not a function. And as far as a graph goes, there's also a very quick test here called the vertical line test. So the vertical line test is something you can use to test if a graph represents a function or not. So a graph is a function if you can draw a vertical line anywhere and it only touches the graph in one point. So, since I have a neat little vertical line tool, let's use it. So, I mean, number 2, why don't we just start with number 2? If I can draw a vertical line anywhere and it only touches the graph once, no matter where and so you can like use your imagination, you could use your finger, you could use your pencil, whatever, to kind of like check all the way across the graph. Is this vertical line ever going to touch the graph in more than one spot? Nope, nope, nope. So this passes the test. This passes the test. But when you move your vertical line, see, it's like passes the test, passes, 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 passes. But once you get to like here, I mean, look at this. This touches the graph here once, twice, 3 times. So that's a fail. And so graph number 3 here is, come on, not a function. So how about this? Let's be careful here. Ooh, well, that definitely looks like a fail, doesn't it? I don't know, but yes, right there, those two. And it looks like, boom, twice, hits the graph twice. Hits it twice, once. So number 1 is also a fail. Okay, so this is a no. This was a yes. And this was a no because of the vertical line test. Now look, this is just like the table thing. This would be a matter of, are there any repeat x's? So 10, 20, 30, 40. There are no repeats, so that passes the test. This is yes, this is a function. But, ooh, you see right there? If you have repeat x's, then it's not a function. And it's that simple. It really is. It's that straightforward. Now, which one of these represents a function? Well, here we just have, it's called a mapping diagram. So here, I mean in W, if the 2 is mapping to the -1, that means we have 2, -1 is an ordered pair. But it looks like it's going to be 2, also 2, 7. And so I think you kind of see where I'm going with this. If you have multiple arrows coming off of the same input value, because remember, input's like X and output's like Y, then W is not a function. It's like we don't have like just 2 times, we had 4. 2, -1, 2, 7, 2, -6, and 2, 5. So definitely not a function. How about down here? -7, 4, so okay. But you see this? We had 2 different arrows coming from the 10, so it would have been 10, 14, and also 10, -3. So it's not Y. And look at here. So it's not Z, but now I know they're all going to the same output, but look, this is going to be 7, 6, -1, 6, 0, 6, and 8, 6. There was no repeat x's. So this is the answer. And so I guess what we have to point out here pretty quick is that, I know it's kind of a double standard, but you're allowed to have repeat y values, but you can't have repeat x values. So I guess back here, when I wrote down the x values are not allowed to repeat, now you know why I only said x values. Because that's really all it is. You know, if you have repeat y values, no big deal, right? It's all about the x values that are not allowed to repeat. The y values can repeat, and that's just the way it goes. Final question here, pretty easy again. If they give it to you as lists, which one describes a function, or which of the following are functions? Once again, you're looking for if there are repeated x values. So number 1, are there any repeated x? See, it doesn't matter about y. It doesn't matter about the y's. It just matters, so that would be a no. 0, 1, 4, 9, that's a yes. Oh, you know what? Why did I just do that? I hate that. You should never make your y's even remotely seem like they could be a 4. Anyway, whatever. -4, -1. Oh, sorry. Can't have repeat x's. 0, 1, can't have repeat x's. So that's a no. And that is section 3.3a.